Hey everyone, my name's Trevor Spires, and today I've got a comparison head-to-head of VMware's kind of two flavors of container networking solutions. I made this video because I think it's a complex subject, and one of my favorite things to do is try to take something that's a little fuzzy, unclear, or complex and add a little clarity to it. I hope that I've accomplished that. If you like it, share it, tell somebody about it. Hopefully it helps you or somebody you're working with. Just right up front, this is not meant to be an exhaustive breakdown of each solution. Simply put, I've given you a high-level overview of each one and then given you a side-by-side comparison of the strengths of both platforms so that you can decide on your own what's best for you or for your customers. Now, I know what's best for my customers and the people that I work with, but my opinion is not the authority. Okay, so I'm hoping that this gets some conversations started around the subject, so that way we can all, both as individuals, learning about technology, or maybe partners or employees of organizations bringing these solutions to customers, can more easily determine what the right path to take is for your customer organization. I'm also going to tell you what I think is the granddaddy of them all, the best thing you can get as far as a VMware solution for networking actually is towards the end of the video. I've made a point to tag below all the different sections of the video, so if you'd like to fast forward straight to the feature comparison I have, do that now. Otherwise, if you need a quick overview of Avi AKO and NCP, keep watching and enjoy the video. Okay, so what I'm going to be covering is the Antrea and Avi based container networking solution offered by VMware. And I'm going to be kind of placing that side by side with the NSX NCP flavor of networking. Just for the record, I want to make this pretty quick, short, sweet, as much as I can. So I do not plan to go down deep on any of these subjects. If any subjects you would like to learn more about, please contact me and I'm happy to make a follow-on video double clicking on any of the topics that we discuss. All right, let's talk about AKO. AKO, or Avi, provides layer 4 through layer 7 load balancing, Ingress, WAF, DNS, and IPAM application publishing and discovery services to your clusters, okay? It's a pretty simple architecture. Avi is a controller-based load balancer, so it has a controller, and then it has these little proxies that it automates the lifecycle and deployment of. And the installation of Avi is a simple pod installation, either via a TKG product line that automates this, or via just a traditional Helm type installation of that pod. You plug that sucker into your controller, and then what's going to start happening is as your consumers are provisioning WAF policies or ingresses or load balancers or global site load balancers, so that's multi-site DNS-based load balancing, as you start provisioning that stuff, it's sent to the Kubernetes API. The AKO pod just listens, and then it will program the Avi controller based on the inputs and translate all of those Kubernetes instructions into load balancing services right up here at the proxy level, what we call service engines. One thing to note about this architecture is it's scalable, which I think is particularly interesting because that means that, Kubernetes can auto scale, or you can change like a variable on the number of pods to scale up and down really quickly. Well, we can provide the exact same functionality, but now in your load balancer with Avi, which is pretty interesting given, if you're scaling the back end, you may very well also need to scale your load balancers. Another thing to consider here is the Avi solution would be deployed outside of the cluster, meaning that the service engines today in UA are sitting outside of the cluster, not internal to the cluster. So your ingresses are outside, not inside. I think this is a great architecture, and it makes a lot of sense because now all of the processing for like layer 7 decryption inspection can be managed in a separate pool of capacity than maybe the cluster itself. So it makes it easier for you to control load balancing capacity without necessarily having the services hosted in your cluster potentially hogging or stealing resources from the actual pods themselves that are running the software. So to me, this architecture makes a lot of sense based on that alone, but there are some other benefits of this that you might look into later. Okay, so that's AKO, and AKO is responsible for that north to south traffic going in and out of the cluster. So now let's talk about the inter-cluster communications. That's done by Antrea and whenever you're using AKO. So the Antrea architecture It's different. It sits inside the cluster. Okay. So with Antrea, it's also a relatively straightforward architecture. There is a control plane that's deployed, so a control pod, the Antrea controller, and then that talks to Antrea agents that are installed on the various nodes. Okay. This takes care of all of your pod plumbing. This can do a lot of other really interesting, important CNI stuff and security stuff. And what I like about the architecture is it's built on Open vSwitch, and it's built in a very programmable way, and it's also an open source CNCF project. So there's contributors from VMware and a lot of other large technology vendors contributing to this product. And I think that this product has a lot of room to grow past where it is today, and it already seems to be growing pretty rapidly. So I personally believe that this is a really solid CNI for a lot of different reasons, and it also has some interesting integrations and is now the default CNI for basically any TKG deployment from VMware. To highlight, what the Avi and Antrea solution looks like from the data plane perspective, is we have those service engines that I mentioned that are sitting external to your cluster, and then so when I provision like an Ingress or a load balancer, a VIP is going to be provisioned, all right, and so that VIP is provisioned, and then from that VIP, we're going to be forwarding traffic down to the nodes, right, either to a node port or node port local, which is an interesting integration between AKO and Antrea that exists from a service perspective. There's also one called cluster IP, but you can use different services as the back end. So basically what happens is as you provision your Ingress and your service and you map those together, your VIP is deployed, and then the pool becomes the node or the pod on the back end, depending on which service type you've actually used as the back end for that. All right. And this is all just done by like a basic tagging relationship. Like you're not configuring the pool manually. You're not configuring the VIP manually. You're just defining your objects, and all of these get strung together behind the scenes by Kubernetes, AKO, and Antrea all working together. Right. So with this, the data plane traffic flow is user hits the VIP forwards or load balances to one of the pods in the pool. That goes into the node, is going to pass through our Open vSwitch and then down through the virtual Ethernet card that's plumbed into each respective pod. So here's the question. Are these solutions better together? My opinion, yeah, they are. These are, in my view, a match made in heaven. Particularly, Antrea does a really good job of providing east to west communications into a cluster, east to west services within a cluster in a way that can run anywhere, right? Any cloud, any type of network underlay. In fact, they can even support multiple types of network underlays simultaneously, hyper flexible, and with a lot of feature richness that's only going to continue to grow, both from the open source side and from the VMware value add side. And then also, Avi AKO, very similarly, can run anywhere, right? It can be deployed on any type of Kubernetes or any type of cloud infrastructure, which makes these two a really good fit for one another because they both have their areas of strength, right? This Avi excels in L4, L7 load balancing, security, and GSLB, as well as being a really high performance solution. And Antrea has all of those same type of tenets, except for it does its own side of the security puzzle with network policy and some extensible security, as well as executing all these other constructs really well. So this is all to say, these two solutions, while they may be separate solutions, are both like very good at what they do, and it's why I think they are certainly a better together story and something that I'm deploying with a lot of my customers right now. By the way, another great thing just about Kubernetes in general is if you need something else, you can always customize it, or again, these are both very rapidly developing products, both from the open source side and the commercial side working together. So if you see something or you find something that doesn't exist in these products, like it will exist, make a little noise about it, talk about it with your peers, because both of these products are absolutely not in their final form. They are rapidly evolving. They both have really impressive release schedules. And I think you'll find that if you start using them, you'll be like, holy cow, there's always new features being integrated. It's quite an exciting time with both of these solutions. Okay, and so for NCP, it follows kind of a unique architecture. I can't really compare it to the other two solutions at all. NCP, it runs on the full NSX stack. So you need to have a NSX license or installed, and you need to have either via VCF or through your own custom installation of NSX, have all of the various NSX components stood up in order to start using this. But once you have your NSX stuff in place, either manually or automated, the architecture is kind of similar in that, your consumers are still going to interface with that Kubernetes API and write out their YAML specs, but NSX and NCP are going to install a bunch of different components on your nodes. And effectively what's going to happen is, as the consumer is configuring their ingresses or network policies or pods, that is all going to be plumbed by NCP. And then where necessary, it's going to execute locally inside the pod with the NSX node agent, but then it's also, under some circumstances, going to proxy configurations into the NSX manager and then translate that into NSX objects, such as tier one gateways, load balancers, firewall rules, etc. Okay, so there's kind of like two things happening at once here, where there's stuff happening internal to the node by plumbing pods into the virtual switch, but then there's also things happening outside in the NSX LAN, external to the cluster, that's being translated. With this solution, there's a lot of nuances in things like TKGS, or you may also hear WCP when you're talking about TKGS as a solution. So I just like to highlight that. You need to kind of understand those nuances and the differences between this and maybe an Avi Antrea solution before you make any hard decisions on which direction you want to go. On the data plane side, remember I was showing you that NCP proxies some of the configuration from NCP to your NSX managers. So basically what that means is, as you're defining load balancers, or as you define a NAT mode, or you're firewalling or whatever, that's going to be proxied into NSXT's tier one gateways for the load balancing, like type LB and then Ingress, right? That's going to be done up here a lot of times. Depending on the config, there's some variability here, a little bit more variability than it may be in the Avi Antrea combo. Okay. And then also what's going to happen is, we're going to automate the provisioning of segments and then plumbing of those segments inside the hypervisor into your various pods. Network policies are going to be relating to distributed firewall rules that are also going to be plumbed down to the pods. And you might ask, like, well, how do we do network policy with distributed firewall? Because distributed firewall is not necessarily going to a pod NIC. It is going to a node NIC, because the node is the VM. Basically, the pods all get plumbed up. So like the firewall policy and the east-west transport is going out of the pod into the NSX world and kind of moving between on basically logical switches in NSX, these overlay networks. So again, if this sounds like a bunch of jargon to you, you might like take an NSX course or read some NSX, or just decide not to go with NCP, because at the end of the day, while it's a robust solution that offers a lot of interesting features that we'll talk about in a moment, you definitely need to have a handle on NSX before you do this. If you don't understand NSX, in my view, it would be kind of strange to throw this into a production environment. You need to make sure you understand what all this stuff is, what it means, and how the constructs relate. So, just to answer the obvious question, why not NCP and Avi and Antrea, right? Why can't you just use both? Well, there's a few reasons. I think the biggest thing is that currently there's a lot of feature overlap, which leads to some compatibility issues when you leverage both of these simultaneously. I can go into detail with you if you want specific information for your circumstance, but simply put, it will not work. There are just issues when you start installing multiple CNIs and multiple Ingress controllers into a Kubernetes cluster. That's not how Kubernetes clusters are really designed to work. I've never seen a customer use multiple CNIs in a cluster or LBs in a cluster. I also believe that while the NCP architecture is interesting, it is not really a good fit for cloud native systems. I believe it's a great fit for VM based systems and applying, the kind of traditional networking in a software defined way. But I think it's also very important to acknowledge that containers are not virtual machines. They do run on virtual machines, and you can treat those nodes as virtual machines, but container networking is different. So because of that, point is you got to choose one. You've got to choose one CNI and one load balancer, Ingress, app services type of solution. And so you have to choose between that AKO Antrea or NCP or something kind of in between as things continue to flux. So what I want to do is walk you through some of the upsides and downsides of each solution and give you my perspective on each of them and kind of call a winner for the certain feature sets. And hopefully it's going to help you decide as you're designing these things out in the field. Okay, here is the comparison. I want to make it crystal clear before I start running through some of these items. This comparison is specifically targeted towards these two options of NCP versus Avi Antrea in the world of a Kubernetes networking solution. Because I know that a lot of people that are maybe big NSX fans might see this list and think, hey, you're not representing the full picture and all this. I'm representing the picture within the context of Kubernetes. That being said, I would just ask, with this, give me any feedback if you feel like there's more important things that should be added here. This is my best effort. I spent a lot of time trying to make it as accurate as I could. I'm going to walk through some of these, give you my opinion on some of these feature sets, the ones that are, to me, really important, the ones that, to me, maybe are less important for a organization wanting to adopt Kubernetes, and just share why I've kind of called a winner on each category, why I came to those particular conclusions, all right? I think first and foremost, I'm going to focus on these bottom three because these three, to me, represent what is actually... other than like when you have a use case for a feature, these three things are the most important things to consider, I believe, when building out a Kubernetes environment. If you know anything about Kubernetes, you understand that the whole idea is to make ops easier, simpler, and faster, right? It's to develop and release software quicker, easier, faster. So that's why I personally am a big fan of AKO Antrea in Kubernetes. And the reason for that is because it's a very low friction install. It is both feature rich but not very complex. At least in the world of Kubernetes, it's about as simple as you can get, I guess. Kubernetes is, in my opinion, inherently complex, so you can't say it's not complex at all. But when comparing an NCP solution versus Avi Antrea, I just believe Avi Antrea to be a much simpler overall solution and much easier to stand up and implement, and for a customer to learn and adopt. This is going to be a lot easier because you don't have to go kind of back in time and learn all of the nuances of NSX and install and design NSX. That's just not needed necessarily for a lot of Kubernetes environments. Therefore, I'm a big believer that we need to reduce friction to ensure customer success, and that's why I'm a big fan of the least friction solution here, which is Avi Antrea in that regard. Now, in terms of ecosystem support, today, as everybody probably understands that knows anything about NSX, it's really tied to the ESXi ecosystem. I think there's some other hypervisor support, but generally it's always deployed on ESXi, which means that you can deploy NSX on-prem and that is it, okay? Whereas Avi Antrea are both multi-cloud solutions. So Antrea and Avi both can exist in basically any cloud. I'm not going to say any cloud ever because there's always new clouds popping up. I'm sure that there are some feature deltas, so reference the documentation here. However, I know for certain Avi and Antrea both support the major cloud vendors that most organizations are deploying clusters in today, as well as they support your on-prem infrastructure. And finally, there's cost, okay? And this is where I'm just trying to be empathetic and put myself in the shoes of a customer where NSX is a robust solution and it has a price point to match that, which is good because there's a lot of value packed into NSX, but you really need the value to justify that price point, right? And so the cost conversation is really highly slanted towards Avi and Antrea because just comparatively, Antrea is open source and Avi is relatively low cost. In fact, Avi is actually included for free with every Tanzu bundle that exists today at VMware. There are different kind of tiers of it. There's 2 tiers to be specific, and I'm going to talk about that next. But just suffice it to say, you're probably already getting this if you're buying TKG, and you might be getting the full Avi. At the very minimum, you're getting a Avi that can support the layer 4 load balancer in Kubernetes. All right. So now what I would like to do is pop through some of these other ones and just shed some light on what all this stuff actually means. I've covered these bottom three because I think those are important. But now I'll talk more about feature function rather than architecture and philosophy, which are these last three. So some of these are going to be really quick. So network policy, as an example, they both support it. I give it to Antrea because Antrea allows you to do custom CRDs for that network policy and do some more RBAC and customization that you're not really able to do with NSX, okay? Some of these are debatable, like the security scope. NSXT owns security for all of your clusters if you do NCP, whereas in Antrea, each cluster is an isolated security domain. I actually think that that's better in Kubernetes, but of course, you could get in a philosophical debate about that. And I would love to get in a philosophical debate with you about that, actually. So please contact me if you think that it's better to do this option. I probably lean Antrea, but who knows? Okay, enforcement. This is like basically where it's enforced. I don't know if it's that important. I kind of like this model just because it aligns with all the other Kubernetes implementations of being enforced inside the node. But that's whatever. IP transport. Honestly, like who's using IPv6 in their Kubernetes clusters? Like, oh my god, like that's nuts. I never even heard of that. If you're doing that, you shouldn't be watching this video. You should be writing a PhD thesis. You're way smarter than me if you're doing that. Okay. IPAM, again, this one's debatable. Either NSX can own your IPAM or you can use AKO/Kubernetes plugins or third-party stuff to do it. I don't necessarily know a lot of customers who want NSX controlling all their IPAM, but some customers do, so that is also debatable. Okay, overlay encapsulation. Antrea gives you more flexibility. There's more options. That's just how it is. IPsec, so that's data in motion encryption. Since Antrea is the only one who supports GRE, it's the only one who can do data in motion encryption today. A lot of customers that use NSXT ask for data in motion encryption. I've heard it asked multiple times out in the field, but it's just something that we don't have. The VXLAN protocol, the VXLAN protocol does not encrypt traffic. All right, so now we're getting into some of the more load balancing focused features. So service type LB, I mean, Avi basically blows NCP out of the water. It's not even close. Architecture alone is a big piece of that, but also there's just a lot of more advanced features that don't exist in NSX that do exist in Avi. The exact same story, in fact, to a more heightened degree with Ingress, because with Ingress we can do all the feature richness that's within the architecture of Avi, but also we can engage CRDs to expand past the Kubernetes API and do a more advanced configuration for enterprise apps that require things like persistence or maybe some kind of different load balancing algorithm or X404 or whatever it is that you require for your app. WAF. NSX doesn't do it. Avi does. Global load balancing. That would be global load balancing, meaning doing like active cluster type of setups. Avi and Antrea do that, and NSX doesn't. By the way, I'll take a moment here just to highlight, like, you could somehow come up with a bass-ackwards NSX design that does multi-site, where like you're stretching nodes across data centers and blah, blah, blah. Please don't do that. For the love of God. Do not run active on stretch layer 2 across your data centers. Are you crazy? Who does that, like it's one thing if these are like different racks connected by high-speed fiber optic links and you've got it all network cabled up and you can actually cluster it to make it function as a single data center, but then there's routing. It's just like, it's not how it's really done. Like, it can sound like an interesting story, but in the real life world, people designing multi-site applications are using either global site load balancing or some kind of CDN. At the edge, and then still probably engaging GSLB behind that. So I just want to highlight that because I don't think stretching layer 2 is a very good solution for multi-site applications personally. I think it's a fine maybe DR solution for legacy apps, but for modern applications like Kubernetes, holy cow, please do not do that. Of all of the things on this list, vSphere pods I'll be honest, is the one that I am least educated on. All I know is that today, NSX and NCP can support vSphere pods, and Avi and Antrea can't. That being said, I've tried, I've asked, I've been like begging people, can somebody tell me what the heck a vSphere pod is and why is it good? And nobody can really answer that for me. I don't really see the value of a vSphere pod today but I probably just don't understand it yet. So if somebody else out there knows about vSphere pods and can really articulate the benefit of that to me, I would love to hear it. All I know right now, though, is that you can't do it. I'm talking about Antrea today. You might be able to one day. I suspect that probably will be something that's available one day, but right now you can't. So I just wanted to call that out, because especially if you're using like TKGS and you're doing what they call a supervisor cluster in TKGS, the vSphere pods are something that come up in the conversation. Again, I don't understand the vSphere pods. I don't really think that they seem that relevant, because if I were building my apps, I would probably be building them on a guest cluster, in which case I would be using a regular, normal Kubernetes pod and not the VMware version of a Kubernetes pod. But I got to just continue saying I'm not as educated on this topic, so I should probably shut up, and I will. All right, cluster IP, they both do it. They do it different ways. And then, okay, NAT and routing modes. This is another one that NSX does and Avi Antrea doesn't, but I don't get it, Like, I've been really studying and reading for the last year or so, trying to enable myself, trying to understand how customers are building on Kubernetes. And across the board, when I talk to people who are actually successful with Kubernetes, none of them are doing this. None of them are. Not a single one I've met are doing this. Now, you can do this. It's a feature within NSX, and maybe it's a requirement. If it's a requirement, then this is going to be a big differentiator for you on the NSX side. But that being said, it's just a little bit fuzzy to me why this is so important to be able to do like SNATs and NATs per namespace, per app, per service type of stuff. Like, to me, the whole idea of Kubernetes is to kind of have this private space for pods that aren't exposed to the public world, and then only expose those via like an Ingress or something, or via an egress when you need to. So that's why I don't really get this. But again, much like the vSphere pods, if somebody does get this and can explain it to me in a way that makes sense, I'd love to hear it. But so far, I haven't met a single customer that this is that important to who's actually successful with Kubernetes. And then finally, by the way, this is a little bit outdated, because I was just reading a blog post that said Antrea started supporting egress SNAT. So double check me on this one, because this might have literally just changed today. I know there was an issue open to put this into Antrea. So in fact, this one might also be debatable now. So I might be contradicting myself that NCP is the winner here. All right, so that was probably too much explanation, but I really wanted to try to give you my best picture of where these all sit in my mind. Again, if you disagree, or especially if you have feedback for me on either of these two and why that they deliver value to customers, I'd love to hear it. So far, from all my research and all my conversations with customers and people that I know, I don't see a lot of value from these, but I do see a lot of value from things like global load balancing and WAF and advanced ingress and all these other things where, oops, it happens to be Antrea and Avi doing that, not NSX.
I debated for a while if I was going to include this slide, but I know it's interesting to some people, so I'm going to cover it very quickly. I just want to highlight the different kind of tiers of Avi that exist within Tanzu. There's really only one tier of Avi, and that is Avi Enterprise. But within the Tanzu portfolio, VMware has started basically giving away this free license that they call Avi Essentials, which allows Tanzu customers to use Avi for the layer 4 only use case. That being service type LB. So with Tanzu Basic and Standard, you get that service type LB in Avi. But if you wanted advanced features like WAF, GSLB, Ingress, Analytics, etc., you would need to upgrade to Avi Enterprise. Now, advanced and enterprise TKG customers do receive the full licensed version of Avi. Now, it's not enough to send hundreds of gigs of traffic into your clusters. If you have like a high performance or like a high load application on these clusters, you might need more capacity, but this will, in these two packages, get you all the features available within Avi. You just might need to double check that you have the capacity necessary. And in terms of the different kind of versions of TKG that are supported, obviously in open source Kubernetes, either of these are supported, and then in a lot of the public cloud Kubernetes, it would only be Avi Antrea, just because NSXT can't extend into the public cloud this way today. But within the Tanzu portfolio, TKGM, I have it on VDS, but really just TKGM in general. It could be on VDS or an NSX port group. That is supported with Avi and Antrea. And honestly, if you're using TKGM, you should just use Avi and Antrea anyway, because TKGM, the M stands for multi-cloud, and these are the multi-cloud Avi and Antrea are the kind of multi-cloud solution in this space on VMware. Unlike NCP, it's kind of on-prem for the most part today, or in some VCF thing. Now, TKGS, this can be TKGS just in general, or TKGS for VCF. Both are supported. There are some nuances still around TKGS on VCF versus TKGS standalone, so inquire about those. I'm personally recommending Avi and Antrea in either model still, but some customers may, for the next few months anyway, still need NCP there to achieve some of their goals, depending on what they want out of the TKGS clusters they deploy. TKGI, this one I'm least knowledgeable on, so I won't comment too much on it. I'll just say that we would support both Avi and NCP in this environment. I believe probably Antrea as well, but I'm not going to speak too strongly on TKGI just because it's the solution that I'm personally least familiar with. But please do not fear my NSX homies and homettes. There are still some really cool value added from the NSX perspective, even whenever you're not using NCP, right? So I'm thinking the granddaddy of them all. Like if you want the real Cadillac of container networking options within your clusters, one thing that might give you the best of both worlds, right? So the ability to get some central control, the ability to implement IPS with an SXT and also have your VM networking automated, right? Would be to do something like this, where you have Avi running your load balancers and running your ingresses for your solution, and you have Antrea doing the east-west networking and the network security within your solution. But you can have an extra layer of security here with NSX. You can enjoy any integration that continues to come between Avi and NSX and CNI and NSX through this interface. And this also still gives you all the same value that NSX delivers for VMs to your nodes, right? Nodes are VMs, so you can apply NSX policy to your nodes, and you can apply NSX policy to your VMs in this central way, which I think is probably pretty useful for people who are managing VMs and want to manage VMs like VMs and manage containers like containers. So my personal hope is that something like this becomes the de facto standard, which basically allows VMware to have a really strong story for the on-prem solution, but then whenever customers are not deploying on-prem, you could kind of chop off this NSX part and then replace this IaaS or VM fabric with your AWS VPCs, your GCP VPCs, or your Azure VNets and networks. All right, so this one was fun for me to make. I hope it was useful for you. I welcome your feedback. Like if you disagree, if you think I missed something or didn't give the full picture here, I'd love to hear your input. I also am redoing my personal blog and website. So if you'd like to follow me, whether it's a subscription on YouTube, on Instagram, LinkedIn, Twitter, or if you'd just like to hit me with an email, go on over to trevorspires.com. Follow me however you like. And that is going to be the hub for my content moving forward outside of what you're watching right now, YouTube, in which case please like and subscribe and comment on this video if you have any feedback or input. Thanks again for watching. These are always fun for me to make. If you have any suggestions or feedback, input based on this video or anything else, you can reach out to me directly on YouTube or LinkedIn. I tend to respond pretty quickly. And until next time, happy Kubernetes, happy customer requirements and discovery and discussion, and happy solutions engineering. All right. Bye, everybody.